class, my name is Miss Alyssa, and today we're going to be talking about normal distribution. During last class, we covered the average standard deviation and the absolute standard deviation, and today we're going to expand on that by doing the normal distribution with the bell curve. The bell curve is a line graph, and it's equal on each side. So the empirical rule of the bell curve is the 68, 95, 99.7 rule. And with this, the middle 68% is what most of the population of the line graph falls within. So broken up, this is 34% and this is 34%. And this is one standard deviation away from the mean. And then on the outskirts, all of that is equal to 95%. So if you subtract 95 minus 68 and divide it by 2, you get that each of these is 13.5%. And that would be equal to 2 standard deviations away from the mean. And then the outer part would be the 99.7%. And that'll leave you with 2.5% on each side. So, with this, we're going to create our own up here. And talk about the standard deviation. So, the mean is always represented by 0, and this is when the mean is equal to the median and the mode. One standard deviation to the left means that it's the average, which is x bar, minus the standard deviation, which is sigma. It's a Greek letter for the standard deviation. And when you go one standard deviation to the right, that means it's the average plus 1 standard deviation. And when you go 2 to the left, since you're going to the left, it's subtracting, and when you go to the right of 0, it's adding. So it would be the average minus 2 standard deviations, and then one more to the left would be the average minus 3 standard deviations. And when you go to the right, it's plus 1 standard deviation, plus 2 standard deviations, and plus 3 standard deviations.
Okay.
The standard deviation, like I said, is represented by sigma, and the mean, or the average, is represented by x bar. Can you tell me what the average of something is? It's the average of all the sets of numbers. So with standard deviation, it's when the mean is equal to the mode and it's equal to the median of the set of numbers. And it's again represented by 0 when it comes to the bell curve. We're going to start by doing an example. And this is the probability that we're picking an x value that's below the mean of the bell curve, and it includes the mean. So what here is represented as 2 below, which here's 0, and 2 below, which would be the -2, and the mean. So what you're trying to solve is what's representing in all of this. So what we're doing is, what would be one standard deviation below the mean?
34.
Okay. And then all you do to find the total would be add them. So what's 2 standard deviations below?
13.5.
So you add that to get
45.5. Or I'm sorry, 47.5.
Okay. And then another example would be picking an x value in between 1 standard deviation below the mean and 3 standard deviations above the mean. So it's represented here as this line here all the way over to the 3rd standard deviation. So it would be, so 1 below would be how many percent?
34.
Plus 1 above.
34.
Plus 2 above.
13.5.
Plus 3 above.
3 above is 2.5.
And when you add these up, what do you get?
84.
84%. Alright. Do you understand that concept?
Yes.
Okay. So next, we're going to be moving on to the z-score. And all the z-score is it's representing sigma. So here is your standard normal table or your z-table. You have that there underneath your paper. And the equation for this is z is equal to x minus x bar over sigma. So x here is your number we're focusing on. And we'll explain that a little bit more when we get into the example problem. And your x bar, do you remember what that stands for?
The mean.
Mean or the average. And the sigma letter, do you remember what that stands for?
Is that the 0?
This is
The standard deviation.
Yes. Okay. And then when we solve for the z-score, we're then going to look if all of these numbers represent what's left on the graph. So when we look at the z-score, we're going to just come over to our table and look up the number. So after we're done solving for the z-score, it's then on our standard normal table that tells us the correct answer.
Oh, okay.
So, before we move on with that, we're going to do another one of our bell curve problems. So, a survey of 20 colleges, students' debt was $3,450 with a standard deviation of $1,175. What we're going to do is find each probability. So, the debt we'll just start over. I'll just crop. Okay, we'll just do this. Do you understand the top portion?
I do.
Okay. So next we'll move on to the example problem that I put up. And this is analyzing the standardized test scores. A test has a mean of 250. The standard deviation, or the sigma, is 50. To solve for how many students would you expect to score over 350, we're first going to begin with setting up our bell curve.
Okay.
So, what would be our zero value, our mean?
250.
250. Okay, and then we're just going to fill in the blanks with 1, 2, and 3 standard deviations above, and then the 1, 2, 3 standard deviations below.
Okay.
What would our first standard deviation? So it would be 250
plus 34.
Plus 50.
Oh.
Because that's our standard deviation, and we're referring back to here, our average plus 1 standard deviation.
Okay. 300.
300, okay. And what would be plus 2 standard deviations?
350.
And what would be plus 3 standard deviations?
400.
Okay. And then working left, it's subtracting. So it would be 250 minus 1 standard deviation.
200.
What would be 2?
150.
And what would be the third?
100.
Okay. So now we're going to look, how many students would you expect to score over 350? So that's 350 and above. So 350 is our second standard deviation. So anything above our second standard deviation would be anything to our third. So if we refer back to our normal distribution chart, which is right here, what percentage is between our second and third standard deviation?
2.5.
Yes. So our answer would be 2.5% would expect to score over 350. For B, how many students would you expect to score at least 200? So when you're looking at 200,
It's
you're
1.
going to draw a line and anything to the right of that because you have at least 200. So we need from our -1 standard deviation all the way to the third. So going back to our chart, what's under the -1 to 0?
34.
Then all we're going to do is add these together.
Plus 34.
Yep.
Plus 13.5. Plus 2.5.
And what does that give us a total of?
84%.
Very good. Do you understand how we're getting all of these numbers?
I do.
Okay. So we're just going to take a little bit of a break. Alright. Next, we're going to talk about z-scores. So your z-score is represented with your sigma. And your equation for this is z is equal to x minus x bar over sigma. Our x is the number which we are focusing on, and we'll talk about this a little bit more when we do an example problem. Do you remember what x bar stands for?
The average
The average. And then the sigma.
is the standard deviation.
Alright, and then this is our standard normal table, and when we solve for our z-score, what we do is go over to this and look up our z-score on the side here,
Okay.
and go over to which standard deviation we're doing, and it'll tell us our answer. So, a survey of 20 colleges, the student's debt was $3,450. The standard deviation is $1,175. Now, next we're going to find each probability. If the debt was at most $3,600. So, first we're going to solve for our z-score. So over here is our z-score equation. So we're having z is equal to x minus x bar over sigma. So I'm just going to rewrite that over here. Okay. So do you want to fill in the equation for us? So what would x represent?
Is 3,600.
Good job. And then our x bar, or our average,
Our average was 3,450.
and then this would all be over our standard
1150.
deviation. 1175.
Oh, sorry.
It's okay. So what we're going to do is subtract and then divide.
So you have 150 over 1175.
So what does that give us a total score? If you could do this on your calculator.
0.1277, so it would be 0.1.
Yep, and then you just round that up to 1. to look on our standard normal chart. And if you go to 0.1 on our standard normal and it's 0, what number do you find under there?
0.5398.
So what we're going to do is rewrite it as the probability that z was at most means less than or equal to. So z is less than or equal to 0.1277. And then you just looked up your 0.1 on the chart and it gives you 0.5398. And that would be the probability of all the debt being at most $3,600.
Okay.
So the next one is pretty tricky because it's an in-between. So the debt between $3,050 and $3,700. So what we're gonna do is just solve for each of these.
Okay.
Solve the z-score. I don't want to know the table yet, just the z-score. So I'm going to write the equations up here for you and then you could solve on your own. And then whenever you get that answer for both of them, just raise your hand. Gina? For the 30/50.
30/50 would be a negative
Okay.
0.34.
Alright. And what can that round to?
Negative 0.3.
Okay. And then what about for the 3,700?
I have a 0.21.
And what can that round to?
Just 0.2.
Okay. Does anybody else have any questions about how we got that? No? Okay. So now we're going to go to our standard normal table and look up 0.3 and 0.2, or negative 0.3 and 0.2. So I already graphed them ahead of time and did z equals 0.2. And if we just look up that number, it's going to give us everything left of 0.2. And what that is on our chart is 0.5793. And then when you look up negative 0.3, what that chart is telling you is everything left of negative 0.3 on our curve. And that number would be 0.3821. Since you don't want to know all of the numbers left of there, you want to subtract them to see what's in between, to get that little sliver of what's in between 0.2 and negative 0.3. So we're going to subtract 0.5793 minus 0.3821 to give us our sliver. And does anybody know what that is? Gina?
0.1972.
0.1972. Alright. So what this tells us is that 0.1972, or 19%, of students' debt is between $3,050 and $3,700.
Okay.
Does anybody else have any questions about how to get that?
Mm-mm.
Alright, and then, so if nobody has any questions, I'll give you your homework, which is pages 372 to 373, 1 through 25 odds. Thank you.